Hello everyone. This lesson we're going to talking about calculation three-phase instrument transformer. So I have a picture here. I have a 3 PTs and the 3 CTs and the 3 wattmeter. Try to measure the three-phase power in this three-phase 4-wire Y-connect supply. So first, the supply voltage, line voltage, 8.3 kilovolts. And the PT have a ratio 4800 volts to 120 volts. CT have a ratio 100 amps to 5 amps. As we mentioned before, usually standard PT output is 120 volts. Usually standard CT output is 5 amps. We have a load, a 3-phase balanced load. Total have 1200 kVA with a power factor at 80%. So first, we can form a PT's ratio and the CT's ratio to find out what's the ratio for them. The PT's ratio gonna be 4800 volt divided by 120 volt, so give us ratio 40 to 1. CT 100 amp divided by 5 amp give us a ratio 20 to 1. If you remember from a second year, we're talking about wattmeters multiplier. The wattmeters multiplier gonna be equal to PT's ratio times CT's ratio. So in this case, 40 times 20 give us 800. So wattmeters multiply gonna be 800. Now let's do the calculation for this one. So we look at those PT's primary is connected in Y because we have a common point connect here. The grounding is for the safety. So my line voltage is 8.3 kilovolts. The phase voltage those PT measuring is going to be the phase voltage equal to line voltage divided by root 3. Do the calculation, give me 4.792 kilovolts. Now, because I know the PT have a ratio 40 to 1, I will know those voltmeters reading gonna be equal to the phase voltage on the primary side divided by the ratio, give me 119.8 volts. The total load is 12 kVA because if we want to find out the current rating on those ammeter, we have to calculate the primary line current. So to find the line current, it's going to be equal to the total kVA divided by root 3 divided by E line. I find the primary, we have a line current 83.475 amps. Now the ammeter reading going to be equal to the primary line current divided by the CT's ratio, give me 4.174 amps. So here's the reading for the ammeter, here's the reading for the voltmeter. But wattmeter only going to read the power. So for this case, we can find out what's the total power on the primary side. The primary side, the kVA times the power factor, 1200 kVA times 80%. So the total power down here for the primary side is going to be 960 kilowatts. So 960 kilowatt is the total power drawn by the three-phase load. Then we can find out the wattmeter, total wattmeter reading, because we have a 3 wattmeter. We're not going to ask you for each wattmeter's reading at this moment. Total wattmeter reading going to equal to the total power on the primary side divided by the multiply for the wattmeter. So I have 1.2 kilowatt for total wattmeter reading. It's a 3-phase balanced load, so each wattmeter gonna read 1/3 of, it's not gonna be that way because we have a power factor down there, the wattmeter's reading, it's not gonna be, it might be slightly different, but we know the total power gonna be 1.2 kilowatts for the total. So here's a calculation for a 3-phase 4-wire Y-connect circuit, and we have a 3 PT, 3 CTs, and 3 wattmeter to read out the power and the volts and amp in this 3-phase circuit. If you have any question, you can always connect us online or send us emails.